Alright guys, we'll see how weird this is. So obviously I'm not here today, but the worksheet you're going to be getting here very soon is on the combined gas law. So you need to take your reference tables out and your notes obviously. You don't really need your reference tables I guess, but on the back is the combined gas law. P1 V1 over T1 equals P2 V2 over T2. So what this equation does is it combines all three graphs that we've already learned about. Pressure, volume, which is indirect, pressure temp, and volume temp, which are both direct. This is a mathematical equation, obviously, that factors in all of those laws into one, hence the name combined gas law. So I'm going to show you two sample problems and kind of work through it with you and show you how to set this up, how to plug numbers in and solve for variables you don't know. And then you're going to be given a worksheet, I think 5 or 6 problems to work on your own at your desk. And I think maybe what you can do is most of the period when I'm done here, work on it on your own, and then you can maybe pair up and kind of compare answers and see how you're doing. Then you're going to hand that in and then we'll go over it tomorrow. So I'm just going to make up a problem here, write it down as I write it down. So here's a typical question. A sample of helium at 298 K with a pressure of 1 atm is heated to, 500 K. Assuming volume is held constant, what is, or calculate the new pressure. So I'll wait a little bit so you get that copied down. I'm going to reread it. So you have a sample of helium gas at 298 K with a pressure of 1 atm. So that's like the initial conditions. So imagine a container with helium in it, pressure of 1 atm.
Please excuse us, one announcement. The boys' soccer game today has been postponed until tomorrow. Still will be at 3 o'clock at Stillwater. Boys varsity soccer practice today, 3:30 to 4:30 in the elementary gym. Thank you.
All right. Game canceled. So good luck to you guys who are playing today on the video. Anyways, so imagine you have a container with helium in it, okay? So helium at 1 atm, 298 Kelvin is the temperature in that initial container. You take that container, you heat it to 500 Kelvin. Remember, we're using Kelvin, not Celsius here. Your next example will have Celsius, we'll have to convert it. Assuming volume is constant, so a container is rigid, right? So it's sealed, like the metal water bottle I always talk about. It's sealed, it's rigid, it's not expanding or compressing. Calculate the new pressure. This is the type of problem you would use the combined gas law. But it's nice because assuming volume is constant, you don't need the V. So when you have your P1 V1 over T1 equals P2 V2 over T2, when you have that equation, if something is held constant, you literally can just cross it off. Since it's the same number here and here, it's constant, you don't need the number, but it would be if you were given a number, it would be the same one here and here. You don't need it. So you can take that right out of the equation. So now, your combined gas law is really, for this problem, P1 over T1 equals P2 over T2. Now, you go back, reread the question, and the way I have always done this is either write the numbers with the variable on the side or label the numbers right in the paragraph. So I'm going to do it that way. I'm going to label each number. So it says a sample of helium at 298. So that's the first temperature they give me. So that's most likely going to be my T1. So that's my T1. So now I know that's going to go right here. With a pressure of 1 atm. That's my first pressure. with the first temperature, so that's my initial. The 1s stand for first or initial. So my P1 is my 1 ATM. There's my P1. All right, it's kind of messy. Sorry. So there's my P1. So you could also over here on the side say P1 is 1 ATM, T1 is 298K. Okay, now we keep reading. Is heated to 500K. So what I always say when I introduce this every year is when you're reading these gas problems, at some point in the question, there's going to be a change. Something's going to change. Something's going to happen. Heated, cooled, pressure increase, pressure decrease. The container expands or compresses, right? So that's our change right here. Anything after that change is going to be the 2s. That's the second condition. That's what happens as a result of the change. So 500K is my T2 because it's after the change. We started at 298, now we heated it to 500, that's going to go right here. So my T2 is 500K. Calculate the new pressure. That's my P2. I should circle it. New pressure is P2. That's right here. That's my variable. That's my X, my unknown. So P2 is my X, question mark, or whatever makes sense to you guys. So I'm trying to go real slow. I may end up giving you just one example. I got to see how long this is taking. I'm not paying attention. But I'm going slow because if you can do this and you can follow me and you can plug numbers in, you can really do any problem I give you. You just have to read it carefully and figure out what variables you're solving for. Sometimes it'll be volume. This time it's pressure. Okay? There is 1 or 2 on the worksheet where you have to use all the variables. So we eliminated volume here. But on the worksheet, you're going to have to keep those in there. And I want to see how you do. All right? Obviously, I'm not here. But it's good practice. Right? It's good practice. And if you screw it up, that's okay. We're going to go over it tomorrow. Plus, when you combine and pair up a little bit here, you know, maybe you can help teach each other if someone's confused. So, anyways, let's finish the problem. So, I'm going to take my numbers here, plug them in. So, I'm just going to erase this here so I can plug in the numbers. So, my P1 is my 1 ATM, so that just goes here. My T1 is 298, that goes here, P1 over T1. My T2 goes here, 500 Kelvin, so that's T2. And then my P2 is X. That's the numerical setup. You're going to see that on tests, the regions. It'll give you this problem, and it'll say, show the correct numerical setup and calculated result. So this is your numerical setup. How do we solve for X? We cross multiply 1 times 500 and then X times 298. So that's going to be 500 equals 298X. Now we solve for X by dividing by 298. Divide by 298. X equals, and I didn't give you any sig fig rules. I think the worksheet does. I'm not sure, but 3 sig figs, we'll say, is a good rule here. 3 sig figs. Let me get the calculator out really quick. So if we do 500 divided by 298, that's 1.67785, so 1.68. 1.68, and this is the biggest issue. The next thing is the biggest issue, labeling units. You do all this work, you have to keep track. What is that number telling us? It's a pressure, right? That was P2 up here. It's a pressure. What is the unit on pressure in this problem? It's ATM, atmospheres. So ATM is the unit. So you want 3 sig figs, the unit, circle or box your number, your answer, and then you move on to the next problem. Show your work, give me the answer, label units, circle your final answer, and then move on. All right, I am going to stop because that probably took a lot longer than I thought. What else is new, right? With me, things take a while. I talk too much, but I went nice and slow. Hopefully, you guys at least are on board with, okay, I get this problem. I know how to plug these numbers in. The worksheet's going to help you practice more. All right, we'll go over that tomorrow. Then there's going to be another worksheet we'll do. So we'll practice this quite a bit. And in lab, we're going to be doing this as well. So everyone will get it eventually. So if you don't get it right now, that's fine. We'll get there. All right? So have a good day, and I'll see you guys tomorrow.